I'm Mike Wheatland from the School of Physics. So I teach and I do research here. My research area is in solar astrophysics. I'm interested in processes that occur in the sun's atmosphere. One topic that I'm pursuing at the moment is to do with solar flares. So solar flares are explosive events that occur in the sun's atmosphere. So energy that's stored in the sun's magnetic field is suddenly explosively released. And so solar flares are actually of interest for quite a few reasons. One is that they directly impact human affairs on Earth. So solar flares and other explosive events at the sun can influence space weather, the local space environment, which causes all sorts of effects on the Earth. It can interfere with radio communications. It can cause radiation hazards for astronauts, for example. It can destroy satellite electronics. And so what we'd like to do is to understand the actual processes that occur during a solar flare, the processes that occur in the sun's magnetic field. What I've been doing with my colleague Alpha Mastrano is modelling the source regions for space weather events, so for these explosive events, solar flares, and that's based on data from the Solar Dynamics Observatory, a large, expensive satellite, a NASA satellite, and we use the data from the Solar Dynamics Observatory as boundary conditions on modelling to model the magnetic fields that are there on the sun. So recently we've been modelling a particular flare that occurred in 2014 that we have a lot of data for. What we're looking at here is the full disk of the sun, or part of the disk. The limb of the sun is at the upper right there. There is this region here that suddenly brightens. What's happening is that a solar flare occurs on the sun, and there's a sudden release of energy from the sun's magnetic field. That energy goes into heating of the plasma, of the gas that's there, and also into the acceleration of particles.
My name is Alpha Mastrano, and I'm a research associate at the School of Physics. And currently, I'm working on solar physics, in particular, the modeling of solar active regions and the evolution before, during, and after flares. We use data taken by the SDS, the Solar Dynamics Observatory, to give us boundary conditions for our models. So the data that we get basically give us the magnitudes of the magnetic fields at the surface. So on the left there, we have the magnitudes of the vertical components of the magnetic field at the surface. Blues are positives and reds are negatives. And on the right-hand side here, we have the basically the horizontal magnetic field magnitudes at the surface. So we use these as boundary conditions to construct something like this. And to show a comparison with actual data, this is the ultraviolet image of that active region during the flare, and this is our model field overlaid on top of the actual image of the actual data taken during that flare. Higher and higher resolutions would definitely help in constraining our model further. And for example, there are things that we don't know yet. Currently, there is no way to get to measure the magnetic field in the corona directly. Maybe in the future, someone will think up of a better way to do this. And for example, the data that we use are basically magnetic fields at the photosphere. There is considerable debate right now whether or not we can get magnetic field strengths at the chromosphere, which is slightly higher than the photosphere. So maybe in the future, they will come up with better ways to process the data coming from the chromosphere and to help us constrain our models better.
I think the data is only going to become more important in my research area. For example, with the data that we're using from the Solar Dynamics Observatory, there's an enormous rate of return of data from that satellite. It's something like 1.5 terabytes per day, and it's basically in the form of 4K images that are produced every 12 seconds of the full sun. In the future, it will be the same thing, but it will be higher resolution and it will be faster. And it's really needed to understand the processes that are occurring. With the 4K resolution, individual pixels correspond to about 360 kilometers on the sun. But we know that in solar flares, the important processes occur on even smaller scales, perhaps down to meters. So there's a demand for higher resolution and for higher cadence of the data coming back. So that the data explosion is occurring. It will continue Looking at the last couple of decades, I think that the big breakthroughs in solar physics have really been led by the observations, by the data. My advice for a new data science student is to not only study data science, but also study a science, for example, physics. You really need to have that fundamental understanding of some area of science to be able to interpret the data and to be able to do useful things with it.